Hello student, today we are going to discuss the next concentration term, which is nothing but a molality. Last class we discussed regarding molarity. Let us look at first how to define the molality and how to solve related problems to the molality. So next concentration term is molality. Molality. One is LITY and previous one is RITY. Molality represented by small m. Molality represented by small m. Molality is mathematically defined by number of moles of solute. Small n is a number of moles of solute by weight of solvent in kg. W is a weight of solvent in kg. So molality is mathematically how we defined. Molality is represented by small m. Molality will be equals to number of moles of solute by weight of solvent in kg. If solvent weight is there in grams, we have to divide it by 1000 to convert in kg. Yes or no? So now you look at first start with one small problem, then it will give a clarity. Suppose I am telling 20 gram of NaOH dissolved in 500 gram of water. H2 means water. Then I am asking what is the molality of solution. What is the molality of solution? Small m is molality. Just now I discussed. So molality will be equals to what we need to do. First I need to find out the number of moles of solute. That value divided by weight of solvent. In this case solvent is a water. Should be in kg. Gram to kg conversion means whatever value of gram is there, you have to divide it by 1000. Then we will get that value in kg. Is it clear? Now to find out the number of moles, in mole concept from beginning onward, I am telling you the different way we can find out the number of moles. Already we discussed the Y map. In terms of a number, given number by Avogadro number. In terms of a mass, given weight in gram divided by molar mass of the substance, that should be in gram. That will give you the number of moles. Here I require to find out the number of moles in terms of a mass. So that's why given weight of solute means NaOH how much? 20. Molar mass of NaOH is how much? 40, because sodium is 23 plus oxygen 16 plus hydrogen 1, which gives rise to 40. So now given weight is 20, molar mass of NaOH is 40, gram is cancel out. That's what I am not putting. So then 20 by 40 is nothing but a 1 by 2 mole. That means half mole. Half mole of NaOH present in 500 gram of water. Then weight of solvent means here solvent means what? Water. In terms of a kg. In kg, which will be nothing but a 500 divided by 1000, which is nothing but a 1 by 2. Now we got the number of moles of solute as well as we got the weight of solvent in kg. Now immediately I will do molality will be equals to number of moles of solute, which is half, by weight of solvent in kg, which is also half, which gives rise to 1. Then molality of the solution is nothing but how much? 1. We got the molality of solution, which is nothing but a 1. For calculate this, what we did? First I find out the number of moles in terms of a mass. Given weight of solute in gram divided by molar mass of solute in gram, we got the number of moles. And the solvent weight is giving in grams. For conversion in kg, we divided by 1000. Then we got the weight of solvent in kg. And then molality as per the definitions, number of moles of solute by weight of solvent in kg. That only I did, half by half, which is 1. Now here another interesting questions, if I ask you, is this molality will depend on temperatures? No. So why molality will not depend on temperature? Because there is no volume term is associated with molality. So this molality, here I am writing, not depend on temperature, not depend on temperature, as there is no volume term associated, as there no volume term associated in it, no volume term associated in it, So that's why there is no question of a dependency of a temperature, because we have a one number of moles of solute is there and other is there weight of solvent, that means mass of solvent in kg. That's why there is no question of a dependency of a temperatures. I hope this small problem everybody understood. Now you look at, if I go to the reverse way, like yesterday molarity come to the reverse way, look at that one. Suppose I am telling how many grams of oxalic acid required to prepare 0.2 molal small m solution. That is the question. How many grams of oxalic acid required to prepare 0.2 molal solution? So what is the meaning of 0.2 molal? That means 0.2 mole of oxalic acid should be present in 1 kg of the solvent. Then only your molality will be 0.2. So for that purpose, if I write down molality, they are telling molality equals to number of moles of solute by weight of solvent in kg. Weight of solvent in kg. Solvent in kg. In kg, this is a number of moles of solute. Number of moles of solute. This one. Now you look at, so molality value they are provided. How much? 0.2. And number of moles of solute I need to find out. Weight of solvent I am putting 1 kg. So then we got the number of moles equals to 0.2. That is the meaning. If 0.2 mole of oxalic acid present in 1 kg of solvent, then only molality is 0.2. So that's why molality keep 0.2. Number of moles need to find out weight of solvent in 1 kg. And then number of moles is coming how much? 0.2. This number of moles means what? Number of moles of solute means number of moles of oxalic acid. Yes or no? Number of moles of oxalic acid. Now, if you look at oxalic acid, generally this formula, last class we discussed these things. There will be 2 water molecule of crystallizations. Molar mass of this one is 126 gram. You can check it out. Now, number of moles of oxalic acid, how much required? That is my question. How much amount required? That is my question. How many grams? The number of moles of oxalic acid requirement is 0.2 to prepare 0.2 molar solution. So now again we know number of moles in terms of a given weight of solute in gram divided by molar mass of solute, that should be in gram. Now if you look at number of moles of solute means oxalic acid 0.2, W of oxalic acid, given weight of oxalic acid I need to find out, molar mass of oxalic acid is 126, then my W will be equals to 126 into 0.2, this much gram. This is your matter hour. You can simplify it, 126 into 0.2. Is it clear or not? So that many gram of oxalic acid required to dissolve in a 1 kg of solvent to prepare 0.2 molar solutions. Is it clear? I hope everybody understood this idea. Now, next one, in terms of a mole fractions, we need to find out the molarity. Very important way of asking molarity. Several times they ask in JEE NEET that type of questions. Now if you look at first, what is called mole fractions? Mole fraction. Fraction means already you understood, out of total particular substance or particular component, how much is there? That is nothing but a fractions. Fraction concept is there 600 onwards. Same thing only. Here only mole fraction. So then fraction means out of 1, percentage means out of 100. Then fraction into 100, always remember, fraction into 100 is your percentage. Then percentage divided by 100 gives rise to a fraction. Fraction means, always remember, this is out of 1, and percentage means, always remember, out of 100. So you will never make a mistake. Fraction into 100 is a percentage divided by 100 is a fractions. So now mole fraction, that means if I give one example, you will understood very clearly. There is a container is there. Suppose I am telling here 2 mole of oxygen is mixed with 3 mole of argon. Now if I am asking, air means argon, inert gas, they will not react. So then immediately if I am asking you mole fraction, how we is to write down? This is called mole fraction. This, how to pronounce it? Chi. This is pronounced as a chi. This is nothing but a mole fraction representation. Then mole fraction of oxygen in this container will be equals to number of moles of oxygen with respect to the total number of moles. Total number of moles means number of moles of oxygen by total number of moles means number of moles of oxygen plus number of moles of argon. That is nothing but a mole fraction with respect to the total particular component, means here oxygen how much is there, that is nothing but your mole fraction. And we can easily calculate the mole fraction of oxygen, because in that container number of moles of oxygen is 2 by total number of moles, that means number of moles of oxygen plus number of moles of argon. Number of moles of oxygen is 2 and number of moles of argon is 3. That's why it is nothing but a 2 by 5. The same way, if I want to find out the mole fractions of argon into that container, so then mole fraction of argon, chi argon, will be equals to number of moles of argon with respect to total number of moles. With respect to total number of moles, which is nothing but a number of moles of argon by number of moles of argon plus number of moles of oxygen, which is number of moles of argon is 3 by number of moles of argon is 3 plus number of moles of oxygen is 2, which is nothing but a 3 by 5. So that's why mole fraction means how many component will be there, maybe 3, 4, 5, 6. Particular component mole fractions will be equals to the mole fraction, the number of moles of that particular substance with respect to a total number of moles. Same way, if you have a container, there is a solute plus solvent is there. Then mole fraction of solute, how we can write down? Will be equals to number of moles of solute with respect to total number of moles, that means number of moles of solute plus number of moles of solvent. Yes or no? The same way, mole fraction of solvent will be equals to number of moles of solvent with respect to total number of moles, which is nothing but a number of moles of solvent plus number of moles of solute. So now if I write down, suppose there are 2 component is there, summation of fraction of 2 component always will be equals to what? 1. If there are 3 component is there, if there are 4 component is there, summation of fraction of 4 component, if you add up the fraction of all the component which is present into that mixture, if you summed up, always it will give rise to what? Whole number, which is nothing but a 1. So same way I can write down, always it is true, mole fraction of solute plus mole fraction of solvent will be equals to 1. Very, very important. Mole fraction of solute plus mole fraction of solvent equals to 1. So then if I know the mole fraction of solute, then 1 minus mole fraction of solute is a mole fraction of solvent. If I know the mole fraction of solvent, then 1 minus mole fraction of solute is nothing but a 1 minus mole fraction of solvent is nothing but a mole fraction of solute. Yes or no? As simple as that. If you know one thing, then 1 minus that one is the other thing. Simple logic. So that way we can find out. This is the first basic idea about the mole fractions, and then whatever component will be there, summation of mole fraction of all those things will be equals to always 1. Now based on that, how they will ask the problem, you will look at. I hope this concept is very easy. Everybody clearly understood this one. Then look at the next problems. In that problem, what they ask? They ask in an aqueous urea solution, mole fraction of urea is 0.2. 0.2 means 2 by 10. 2 by 10 is nothing but a 1 by 5. Is it clear or not? So now in an aqueous urea solution, mole fraction of urea is 0.2. What is the molality of solution? What is the molality of solution? Molality of the solutions. What is the molality of the solution? Is it clear? This is the problem they asked. In an aqueous urea solution, mole fraction of urea is 0.2. And what is the molality of the solution they are asking over here. Before going to discussion of these things, we need to know one idea. If we know that concept, directly I will put that concept and we can solve in a fraction of a second. If you look at that one, before going to that one I am proving. Suppose I am telling W gram of solvent holding n mole of solute. Then what I can write down? Then my molality will be equals to small m. Number of moles of solute is n by weight of solvent in kg. That's why this is 1000. Then you are getting number of moles of solute into 1000 by weight of solvent in kg. W gram of weight of solvent in gram. N is a number of moles of solute. Now what I am doing, this is weight of solvent. Now what I am doing over here, this weight of solvent which is there in gram, now I am divided by molar mass of solvent, that also is gram, and here multiplied by molar mass of solvent. That means I am not doing anything, yes or no? That means this molar mass of solvent will cancel out. Then here we are getting given weight by molar mass is a number of moles. That means what we are getting, molality will be equals to number of above n is a number of moles of solute into 1000 divided by this. Here we are getting a number of moles which is nothing but a number of moles of solvent into molar mass of solvent. This one we are getting. These things again I can write down by dividing. Here also I can divide it by total number of moles. Here also I can divide it by total number of moles. That is only I am doing. So this is number of moles of solute by total number of, in total means total number of moles into 1000, and here number of moles of solvent divided by total number of moles, and here molar mass of solvent is there. Now you look at, I am not doing anything. Here also I divided by n total, and here also I divided it. This n total will what? Cancel out. Then again ultimately finally what we are getting? Molality will be equals to, you look at number of moles of solute with respect to total number of moles, which is nothing but a mole fraction of solute. So then here we are getting which is nothing but a mole fraction of solute into 1000. Numerator we are getting mole fraction of solute. Why? Number of moles of solute by n total is there. Then below denominator what we are getting? Number of moles of solvent with respect to the total number of moles, which is nothing but a mole fraction of solvent into molar mass of solvent. Now our formula is ready for this problem. Then molality will be equals to, how also in terms of a mole fraction we can express the molality. Molality will be equals to mole fraction of solute into 1000 divided by mole fraction of solvent into molar mass of solvent. All data is there. You look at, they are telling here urea is a solute and aqueous means water is a solvent. And now mole fraction of solute means mole fraction of urea is 0.2. So then mole fraction of solute, which is nothing but a urea, that is they are telling 0.2. Then mole fraction of solvent, which is nothing but a water, and which will be nothing but a 1 minus mole fraction of solute, 1 minus mole fraction of solute, which is nothing but a 1 minus 0.2, which is nothing but a 0.8. Then mole fraction of solvent we got 0.8, mole fraction of solute we got mole fraction of solvent 0.8, mole fraction of solute is 0.2. Then molar mass of solvent, then water is a solvent. Then all data we have, you look at, instead of mole fraction of solute, what value I have to keep over here? 0.2. In presence of mole fraction of solvent, I have to put 0.8. Then molar mass of solvent is a water molar mass is how much? 18 we have to put. You look at here, all the data we have. Instead of mole fraction of solute, I have to keep 0.2. Here I have to keep 0.8, and here I have to keep 18. That means ultimately our molality calculations, what is coming? 0.2 into 1000 by 0.8 into molar mass of solvent 18. This is your calculations of molality. You can simplify, I hope. So that is a very, very important idea, the molality in terms of a mole fraction. What is the formula? Mole fraction of solute into 1000 by mole fraction of solvent into molar mass of solvent. Easily you can get it. First of all, you look at how we derive this one. Okay, I hope everybody understood this point. One or two times, if you little practice, you will go through this one. It is not that much hi-fi thing is there. It's not a very hi-fi rocket science is there. Very simple. If you just go through one or two times practice, it will come to you. No issue. Okay, is it clear? Let us go with the next idea, how to establish a relation between molarity and molality. After that, that type of problem which used to come in JEE, that also I will discuss. Look at that one. If you look at, I am telling, let capital M molar solution has a density d gram per ml, and molar mass of solute, I am telling, solute I am telling is M2. Same solution molality is nothing but a small m. Then I need to find out what is the relation between this capital M and small m. That means molarity versus molality. You look at, whenever they are giving conversion of molarity to molality or molality to molality, by default they have to give the density data. Why? Because molarity means volume term associated, whereas molality means weight of solvent, mass of solvent is associated, and volume and mass is connected via only one common term, that is nothing but a density, because density equals to mass by volume. By default they have to give the density, otherwise we can't establish a relations, because only one parameters, which is nothing but a density, which is connecting volume and mass. That's why whenever there will be interconversion of molarity to molality or vice versa, they have to have provide you density data, otherwise it is not possible. Is it clear? So now you look at here how we will proceed to establish the relation between capital M and small m, that means molarity with a molality. Now if you look at, I am telling you what is the meaning of that things M molar. That means M mole of solute solute present in 1000, 1 liter of solution means 1000 ml of solution. Yes or no? That is the meaning of molarity. Number of moles of solute by weight of solvent in liter. Molarity M means M mole of solute present in 1 liter of solution, or 1 liter of solution means 1000 ml of solution. Now you look at density of solution d gram per ml. What is the meaning of density? Per unit volume mass is nothing but a density. That means 1 ml of solution has a mass d gram, small d gram. And we have a considering how much volume of the solution? 1000 ml. Then 1000 ml solution mass is 1000 ml solution mass will be equals to 1000 into d gram. As simple as 1 apple 10 rupees, 10 apple 10 into 10. 1 ml solution mass d, then 1000 ml solution mass into is equals to 1000 into d. So then we got that much. Now you look at, here we got the solution mass. Then m mole of solute is present and molar mass of solute is m2. Then weight of solutions will be equals to weight of solvent plus weight of solute. Yes or no? Because solution is composed by two components, solute plus solvent. So that's why weight of solution means weight of solvent plus weight of solute. Then if you look at weight of solution, then immediately what we can write down, that weight of solution equals to weight of solvent plus weight of solute. Then weight of solution we got it how much? 1000 ml of solution weight or mass how much? This much of gram. 1000 into d gram. Then weight of solvent I need to find out. Weight of solvent I need to find out. Then weight of solute how much? M mole present into 1000 ml. Then molar mass of solute is M2. Then weight of solute will be equals to plus M into M2. This is the weight of solute. Then weight of solvent will be equals to 1000 D minus M into M. This is in what? This will be in gram. So in kg it will be nothing but a D minus MMT by 1000. D minus MMT. Here 1000 D is there. 1000 D minus MMT by 1000. These will be in your kg. Because gram to conversion to kg conversion means what? Divided by 1000. We got weight of solvent in kg. Then molality will be equals to number of moles of solute, which is m mole. Weight of solvent in kg, which is nothing but a 1000 D minus MMT by 1000, and that's why 1000 is coming over here. As or no? Now we got these things over here itself, that now here from there also you look at, you can simplify, but no need directly you can utilize this one to calculations of molarity versus molality. You look at what is the relations molarity, we can simplify but no issue, same thing ultimately. So then here small m is there, here capital M is there, and that is the relation between small m versus capital M. Yes or no? Clear or not? Understood? Everybody clearly understood these things? So we calculated all those things. Simplification if you want to do, you can do. How you can do? Like this. Suppose this part you multiplied with this. So m into 1000 D minus MMT equals to m into 1000. These things. Now here MD into 1000 minus small m capital M MM2 by, here if I do 1000, okay na, here I am doing 1000 equals to this one. Then here we are getting, you look at MD, 1000 will cancel out, minus MMT by 1000 equals to m. Now, if I take small m common, so then what we are getting? D minus mmt, D minus, capital M mt by 1000 equals to m. So then immediately if you look at, then molality will be equals to, you can put it, small m will be equals to m by D minus mmt by 1000. This is, you can do it. So same thing only, we did some simplifications. That means we just do it, that simplifications over here, or directly you can utilize these things, no issue. Yes or no? This is a very, very important concept. But this much of remembrance is not required whenever the problem will come. That relation of these big things not necessary, not required at all. Why? Because the idea is, if I remember the concept of molarity and molality properly, without this I can do it. How we will do it? Let us take one JEE problem, conversion of molarity to molality. Then you will get to know how to do with the concept, not to remember too much of formulas. Is it clear or not? Let us look at. JEE asked one here, 2 molar aqueous urea. Urea means everybody knows, NH2 CO NH2, urea. Urea molar mass, you check it out, it should come 60 gram. So 2 molar aqueous urea solution has a density 1.2 gram per cc. Cc means ml. Then their first question they are asking, molality of solution, molality of solutions. Second question they are asking, mole fraction of solvent in it. Mole fraction of solvent in it. That was the questions, 2 questions they asked based on these data. Look at the problem very clearly. They are giving 2 molars aqueous urea solution. Urea means NH2 CO NH2, 2 nitrogen, 14 into 2 28, 4 hydrogen plus 4 32, 32 plus oxygen 16, 48 plus 12, which is 60 gram. So urea molar mass is 60 gram. Now 2 molar aqueous urea solution has a density 1.2 gram per cc. Then first question they are asking molality of solutions. Second question they are asking mole fraction of solvent in it. Solvent is aqueous, means water is a solvent, urea is a solute, and together they are making a solution. This is the thing is clear to me. Now next, how I am doing this problem. What is the meaning of 2 molar? That means 2 mole of urea present in 1 liter of solution. 1 liter or 1000 ml of solution. Yes or no? Tell me. कुछ तो बोला करो यार. So 2 mole urea present in 1 liter or 1000 ml of solutions. Then only my molarity will be equals to 2. Number of moles of solute by volume of the solution in liter, which gives rise to a molarity. So then we got the molarity idea. From there we understood there are 2 mole of urea is present in 1000 ml of solution. Then you look at the density data they provided. Density is 1.2 gram per cc. That means 2 gram per 1.2 gram per ml. Then 1 ml of this is the nothing but what? 1.2 gram per ml. That means 1 ml of solution has a mass of 1.2 gram and 1000 ml solution is there, because molarity means per liter. Then 1000 ml of solution mass will be how much we need to calculate. Then 1000 ml solution mass will be equals to 1.2 into 1000, which is nothing but a 1200 gram. And we know solution mass will be equals to solute mass plus solvent mass, as because of the solution is composed by solute plus solvent. So solution mass is 1200 gram, and we know out of 1200 gram solute present in 2 mole. Then solute mass in solution, mass in solutions, which will be equals to 2 into 60. So moles to the amount of the substance multiplied by molar mass. You look at everywhere by math. So that's why 2 into 60, which is nothing but a 120 gram. Then solution mass is 1200 gram. Solute mass is 120 gram. Then solvent mass will be equals to solution mass minus solute mass is a solvent mass. So then solution mass is 1200 minus solute mass is 120, which is nothing but your 1080 grams. Yes or no? Clear or not? Then solvent mass is how much? 1080 gram. Then we got the solvent mass is in gram. Now molality means what we need to do? Molality will be equals to number of moles of solute, means urea, which is 2, by weight of solvent in kg. Solvent weight is 1080 gram. Kg means divided by 1000. This is your calculation for molality. Is it clear or not? I hope you can do the simplifications. So this way we can calculate the molality. Am I use any formula? Am I use? No. From where I did? From the concept. How many formula you will remember here? So if your concept are solid enough, you can proceed with that. Now if you look at, suppose they are asking mole fraction of solvent in it. Now we understood in that solution solvent mass was there 1080 gram and solute mass is there 120 gram, means 2 mole of solute is there. Then number of moles of solvent means what? Water, because they are telling aqueous, my dear. Aqueous means what? Water. Then number of moles of solvent means weight of solvent in gram divided by molar mass of solvent, means molar mass of water, which is nothing but 18. I hope it will come around 60. You can check it out. That is the number of moles of solvent. Then once we got the number of moles of solvent is this, and then number of moles of solute already we know, which is urea is nothing but a 2. Then mole fraction of solvent, that is their questions, mole fraction of solvent equals to number of moles of solvent by number of moles of solvent by total number of moles, means number of moles of solvent plus number of moles of solute. That is the mole fraction. Then number of moles of solvent is 1080 divided by 18 by number of moles of solvent, which is 1080 by 18 plus number of moles of solute, which is nothing but a 2. This is your simplifications you can do and you will get your answers. Is it clear or not? So it's a very important idea to understand the interconversion of molarity to molarity. Even I show you the formula also, but formula not required to remember. So everything, if you have a clarity on molality, easily you can proceed with that type of problem. I hope everybody understood this concept very clearly. Later on also we will discuss more problem on this. Okay. Thank you very much. Thank you all.